In this lesson, we are going to talk about vectors. What is a vector? A vector is a quantity that has both magnitude and direction. So there are vectors and there are scalars. A quantity that has only magnitude but no direction is a scalar. And then a quantity that has both magnitude and direction is a vector. So on one hand, we have vectors, and then on the other hand, we have scalars. So what are some of the quantities that are vectors? For example, the force is a vector. Another vector quantity is electric field. That is also a vector. And then the magnetic field is also a vector. These quantities have both magnitude and direction. Then examples of scalars, we have the speed. The speed is only a magnitude. It only has a magnitude. It doesn't have direction. Then the mass of an object is also a scalar quantity. Also temperature. Temperature of an object is also a scalar quantity. It has not got any direction. Then another vector quantity we can talk about is the velocity. Velocity is also a vector quantity. Acceleration is also a vector quantity. So these are some examples of vectors and scalars. So a vector, for example, if we start from a point, maybe let's say A to a point B, the magnitude between point A and B and also the direction in which you took would describe your vector when you move from point A to point B. And when you move from point A to point B, in terms of vectors, it is written as A, B with this arrow on top. Sometimes two vectors can also be represented as bar vectors. So instead of writing maybe vector A like this or vector B in this form, you could choose to write vector A with just this small dash on top, or vector B with just this small dash on top. All of this represents vectors. So now let's talk about position vector. A vector that is measured with reference to a fixed point is a position vector, or with reference to an origin is a position vector. So let's assume that this is our origin, O. It's usually represented with O. If we move from O to a certain point here, let's say P, then the vector OP is a position vector. Also, if a vector A like this is equal to the vector B, what does this mean? It means that the length of A, which the length is usually represented as in this form, or in other words, the magnitude of A equals the length of B. So it's also equal to the magnitude of B. It also means vector A and B are in the same direction. So if vector A is equal to vector B, first it means that the magnitude of vector A is equal to the magnitude of vector B. And it also means that vector A and vector B are in the same direction. Now, if two vectors are in the same direction, it means that those vectors are parallel vectors. And we write parallel vectors as vector A, then with this forward slashes, two forward slashes, and you write vector B. So this is how you show mathematically that two vectors are parallel. So let's talk about addition and subtraction of vectors and subtraction of vectors. So For example, let's assume we have this vector in this form, which is going in this direction, vector A. And we also have another vector in this form, which is going in this direction, vector B. How do you add vector A and B? Where the head of A is, you start vector B by putting the tail of vector B at where the head of vector A is. So this is what I mean. Vector A is in this form. So the head of vector A ends here. So you start vector B by putting the tail of vector B at where vector A ends. So this is vector A. This is vector B. So we are moving from maybe this point to this point. So how do you add the two? It is equivalent to moving directly from point A to point B. And in that manner, you add vector A to vector B. So this is how to add two vectors. Just place the tail of the second vector on top of the head of the first vector and add the two. Now, this addition of vectors is also known as the resultant. So if you don't see the sum, you will also see this word, which is the resultant vector. And we always get the resultant vector when we complete the triangle. So vector A, vector B. To get the resultant vector, you have to complete this triangle by finding A plus B. Now, it is also possible to multiply a vector by a scalar. So for example, if you have vector A plus vector, so for example, if you have, let me write it here, vector A plus vector A plus vector A. Instead of adding vector A plus vector A and then adding another vector A, you see that there are three vector A's. So this is equal to 3 times vector A. So this 3 is a scalar and then A is a vector. So you could just multiply 3 by the vector A. Finally, let's talk about unit vectors. If, for example, A is a vector, then we shall write the unit vector as A cap. So this is vector A, and this is the unit vector of A. So this is the difference. If you see A with a bar, it's a vector. However, if you see A with a cap, we are talking about a unit vector. Remember the definition of vectors that we gave. We said a vector is a quantity that have both magnitude and direction. And therefore, by rule of thumb, you find a vector as vector equals the magnitude of the vector times the direction of the vector. There is this formula for unit vectors. So for example, let's assume that A is a vector and A cap is a unit vector of A. Then A cap, which is the unit vector, is equal to vector A divided by the magnitude of vector A. So a vector divided by its magnitude is the unit vector. So let's assume we have arrangement of vectors in this form and we are supposed to find the vector AB. So we've already established that we find the sum of two vectors by placing the tail of the second vector on the head of the first vector. You can see that OA is the position vector of A and then OB is the position vector of B. So AB is equal to the vector AO. So from the head to the tail, from the tail of vector A to the head of vector B plus OB. So we ended at O. We need to start the vector B from where we ended, which is O, back to B. But from what we've seen in the picture, we see that the vector is going from O to A and not rather from A to O. And therefore, to be able to find AO, we need to negate OA. So therefore, this is equal to minus vector OA plus OB, because the direction of AO is opposite to the direction of OA, and that's how come this becomes minus. What is the vector OA? It is the position vector A, and therefore this becomes minus the position vector A, then plus the position vector B, because OB is the position vector B. So this is equal to, I want to write the position vector B first, so it becomes B minus A. So this is the way to find AB. So for example, if it was not AB, maybe we're given MN, then MN is equal to the position vector MO plus ON, and this is equal to the position vector M. However, the position vector M will become minus M, then plus the position vector N, and this is equal to position vector N minus position vector N. So you can see from these two examples that it is the second position vector minus the first position vector. And therefore, if you are asked to find SR, it is going to be the position vector R minus the position vector S. Find the vector joining the points P, 2, 3, and Q, minus 1, minus 2, directed from P to Q. So the vector is from P to Q. So it's the vector PQ. I will know that PQ can be written as the second position vector, which is OQ, minus the first position vector, which is OP. And this could be written as vector Q minus vector P. And what is vector Q? Vector Q is column vector minus 1, minus 2, then minus vector P. Vector P is 2, 3. So this is equal to minus 1 minus 2 is minus 3. And minus 2 minus 3 is minus 5. And therefore, the vector PQ is equal to minus 3 minus 5. Vectors can be represented in 3 forms. We could represent a vector in the coordinate form, which is this form, the question gave us. This is the coordinate form of vector representation. Or we could also represent it in a column form. So this is a column form. The column form is how I change the vectors into. So this is a column form of vector. This one too is a column form of vector. And then the last form is to use the unit vector I and j to describe the vectors. So for example, this vector P could be written as the I component is I, and then the Y component is j. So this P could be written as 2I plus 3j. This is the third form of representing a vector. So we could have the coordinate form, the column form, or in terms of I and j. Now let's talk about the internal and external divisions of a line. For example, if we have a line AB, we have 2 points AB on this line, and then this line is divided C in the ratio m is to n. Then what is the x component and then the y component of C? So at this point, the x component is x1 and then the y component is y1. Then at the point C, the x component is x and the y component is y. And at the point B, the x component is x2 and the y component is y2. So what relation would join x2, x1, and x2 with reference to the ratios in which the line was divided? The way in which this line has been divided is called the internal divisions of a line. For the internal divisions of a line, we need to use similarities of triangles. So you see that we have two triangles here. And by the condition for similar triangles, you know that two triangles are similar if they have two corresponding angles equal. So you see that this is 90 degrees and this place is also 90 degrees. So this is one corresponding angles that are equal. We need to find the second one. So you see that this angle and this angle are also equal. So because we have these two angles equal to the two angles of this triangle, it means that this triangle and this triangle are similar. So they have their lengths similar. And because they are similar, it means that the corresponding lengths are also equal. So this means that this length AE is equal to the length CF. And then this length, which is CE, is also equal to the length BF. And this length, which is BC, is also equal to the length CA. So we've said that AE, which is this length, is equal to the length CF. So the magnitude of AE in ratio to the magnitude of CF is equal to this part, which is CA and then CB or BC. So what we are saying is that the ratios of the magnitude of AE, which is this length, with reference to CF, is equal to the ratio of the magnitude of CA, which is this side of the triangle, this length, with reference to CB, this length. So now, this means that magnitude of AE divided by magnitude of CF is equal to magnitude of CA divided by magnitude of CB. What is AE? AE is this length. What is the length between AE? You see that E is X and then A is X1. So the length between AE is X minus X1. So AE, let me write it here. AE is equal to X minus X1. What about CF? CF is equal to X2 minus X. What about CA? Of the magnitude of the distance between C and A, which is M. So CA is equal to M. And then CB. CB is this length. So CB is equal to N. The length between C and B is N. So let's go ahead and then insert all of these values into this equation. So AE is X minus X1. divided by CF, which is x2 minus x, equals CA. CA is M divided by CB, and CB is M. So let's cross multiply. So it becomes N times x minus x1 equals M times x2 minus x. So let's expand the bracket. N times x is nx minus n times x1 is nx1 equals m times x2 is mx2 minus m times x is mx. So there is x here and there is x here. So let's group like terms. So we have nx, then I'm taking mx to the left hand side. So minus mx becomes plus mx equals this, which is mx2, and I'm taking this term to the right hand side. So minus nx1 becomes plus nx1. So I want to factorize x out of these two terms. So it becomes n plus m in one bracket times x equals mx2 plus mx1. So let's divide through by n plus m and divide this place to by n plus m. This n plus m and this n plus m can cancel out. So x is equal to mx2 plus nx1 divided by n plus m. So this is the x component for the internal division of a line. So let me write it down here. What is the magnitude of CA? CA, it is M. Okay, we already have CA here. We have CB here. So we are done with this portion. So let me find magnitude of CE. CE is CE. So it is y minus y1. Y minus y1 is CE. And let's find BF. Magnitude of BF equals y2 minus y. So it's y2 minus y. So CA is M divided by CB, which is N, equals CE, which is y minus y1 divided by BF, which is y2 minus y, y2 minus y. So let's cross multiply in this case too. So it becomes m times y2 minus y is equal to n times y minus y1. So let's expand. My2 minus my equals ny minus ny1. So there is y in this place, y here. So let's take this y to this side and bring ny1 to this side. So we have my2, then minus ny1 becomes plus ny1 is equal to my, then minus my becomes plus my. So let's factorize y from this portion. So we have n plus m times y is equal to my2 plus my1. So if we divide through by n plus m, divide this portion to by n plus m, this and this cancels out. So we see that y is equal to my2 plus my1 divided by n plus m. So the x component is mx2 plus nx1 divided by n plus m. And the y component is my2 plus ny1 divided by n plus m. So in other words, we just replace x2 by y2 and x1 by y1, and everything remains the same. So these are the formulas for finding the internal divisions of a line. So let's write down the column vectors. The column vector A is -1 and 5, and the column vector B equals -1 and then 2. So instead of A, let me write it as OA and OB, which are the position vectors. So position vector A is in the form of column vectors is written as -1 and 5. And position vector B in terms of a column vector is -1 and 2. And then the question is saying we should find BA. I will know that BA is the second position vector, which is OA, minus the first position vector, OB. This is equal to, what is OA? It is -1 and then 5, then minus OB. OB is -1 and 2. And this is equal to -1 minus -1 is -1 plus 1, which is 0. And then 5 minus 2 is 3. And therefore, at the end of the day, the question says we should leave it in the form of a column vector. So BA is equal to 0 and 3, 0, 3. Let's find BC. You can pause the video at this point and find BC. BC is the position vector of C, which is OC, minus the position vector of B, which is OB. So OC is 3, 0, minus OB is -1 and then 2. And this is equal to 3 minus -1 is 3 plus 1, which is 4. And 0 minus 2 is -2. And therefore, the vector BC is equal to 4 minus 2. Given that vector M is equal to 3i plus 5j, and vector N equals 2i minus j, and vector R is equal to 5i plus 17j, find magnitude of 3m minus 2n minus r. So in terms of a column vector, vector M is equal to 3, 5, and then vector N is equal to 2 minus 1, and then vector R is equal to 5 and then 17. So let's first find 3m. So 3m is 3 times vector m, which is equal to 3 times this vector m, which is 3, 5. And that is equal to 3 times 3 is 9, and 3 times 5 is 15. So 3m is 9, 15. And let's find 2n. So 2n is equal to 2 times the vector n. And the vector n is 2 minus 1. 2 times 2 is 4. And 2 times -1 is -2. Then the last part is r. But we know that r is giving us 5 and 17. So let's go ahead and find 3m minus 2n minus r. So 3m minus 2n minus r equals 3n is 915, then minus 2n is 4 minus 2, then minus r is minus 517. So writing this as one column vector, it becomes 9 minus 4 minus 5, and then down here becomes 15, minus 2 becomes plus 2, then minus 17. This is equal to 9 minus 4 is 5, 5 minus 5 is 0, then 15 plus 2 is 17, 17 minus 17 is 0. So at the end of the day, 3n minus 2n minus r is equal to 0, 0. In other words, this could also be written as 0i plus 0j. But the question said we should find magnitude of 3n minus 2n minus r. And this is equal to the square root of 0 squared plus 0 squared. And this is equal to 0 units. The position vectors of points A, B, C, and D with respect to the origin are into bracket 2i minus 4j, 5i plus 3j, 8i minus 2j, and xi plus yj, respectively. If ABCD is a parallelogram, find the position vector of D. So let's draw a parallelogram. So this is the diagram of a parallelogram, and then we have A, B, and then C, D. But the coordinates of A are the first vector, which is 2 minus 4. Mistake here. This is minus 2i minus 4j. So therefore, the coordinates of A are minus 2 minus 4. And then the coordinates of B are 5i plus 3j, which is 5, 3. And then the coordinates of C are 8i, then minus 2j. And then the coordinates of D are x and y. So we are supposed to find the position vector of D. However, you know that this line DC is parallel to AB, and also this line AD is parallel to BC. So therefore, vector AB is parallel to the vector DC, and also the vector AD is also parallel to the vector BC. So since they are parallel, we can use one of these to find the coordinates of D. So let's use the first one, AB parallel to DC. So let's find the vector AB. Know that the vector AB is the position vector OB minus the position vector OA, and OB, what is it? OB is 5, 3 minus OA is minus 2 minus 4. And this is equal to 5 minus 2 is 5 plus 2, which is 7. And 3 minus 4 is 3 plus 4, which is also 7. and therefore vector AB is 7I plus 7J. Now let's find the vector DC. The vector DC is position vector OC minus position vector OD. What is position vector OC? It is 8 minus 2 minus position vector OD. OD is XY. So this is equal to 8 minus X is 8 minus X minus 2 minus Y. So this part is minus 2 minus Y. But we've already established that the vector AB is parallel to the vector DC. And since they are parallel, it means that the vector AB is equal to the vector DC. So vector AB is equal to vector DC. And since they are equal, it implies that AB is what? 7, 7 equals DC, which is 8 minus X and minus 2 minus Y. So this implies that 8 minus X is equal to 7 and X is equal to 8 minus 7. So X is equal to 1. And minus 2 minus Y is equal to 7. So Y is equal to minus 2 minus 7. Therefore, Y is equal to minus 9. So the X value is 1 and the Y value is 9. And therefore, D of XY is equal to 1 minus 9. P, Q, R, and M are points in the OXY plane. If PQ equals 2I plus AJ and PR equals 11I minus 12J and M divides QR internally in the ratio 3:7, find PM. So let's sketch. So PQR. So since there are 3 points, then we can know that this is a triangle. So let me sketch it here. So let's assume we have this triangle. And then this is the point P. And this is the point Q. And then Q is 2, 8. And then the point R. R is 11 minus 12 because it is 11I minus 12J. Now, this divides this triangle in the ratio. M divides this triangle in the ratio 3:7. So let's assume the point M is here, M of XY. And this is the ratio 3 and 7. Let's draw a vertical line from P to M. So the question is saying we should find PM, which is this line. So PM is equal to the vector that moves from P to Q plus the vector that moves from Q to M. So PM is equal to PQ plus QM. But from the question, we know the vector PQ, which is this vector. Now, what we don't know is QM. So we need to find QM. The vector QM is equal to, is in ratio 3:7 with the vector QR. So QM will be just 3 divided by the total ratio, which is 3 plus 7, which is 10. Then times the vector QR. But we need to find this vector QR. And we know that QR, by the addition of vectors, is this vector QP then plus this vector PR, that is the vector QR. So what is the vector QP? The vector is moving from P to Q. So QP will just be the negative of PQ. So this is equal to the column vector. Instead of 2, 8, we just write minus 2, 8, and then plus PR. PR is this vector 11 minus 12. So minus 2 plus 11 is 9, and minus 8 minus 12 is minus 20. So the vector QR is 9 minus 20. But we said QM, this vector QM equals 3 over 10 QR. So we need to multiply this vector by 3 over 10. So QM is equal to 3 over 10 times 9 minus 20. So 9 times 3 over 10 is equal to 2.7. And then minus 20 times 3 over 10 is minus 6. And therefore the vector QM is 2.7 and minus 6. So since we know QM, we can find PM, because we already said PM is equal to PQ plus QM. So PM is equal to, what is PQ? PQ, it is 2 and 8, then plus QM. QM is 2.7 and then minus 6. So PM is equal to 2 plus 2.7 is 4.7, and then 8 minus 6 is 2. So the vector PM in terms of I and J is equal to 4.7I plus 2J. Points A and B have position vectors. A equals 2I minus 3J, and B equals minus I plus 2J. Find the position vector of the point M on AB such that magnitude of AM in ratio with magnitude of MB equals 3:2. So let's draw a line. Let's assume that this is the point A, which is 2I then minus 3J, and then this is the vector B, the point B, which is minus 1, 2, and then M divides it in the ratio 3:2. So let's assume this is MXY and the ratio is 3:2. The question says that we should find the position vector M. So let's find the X component of M. So X is internal divisions of a line. It is MX2 plus MX1 divided by M plus N. So M times X2, which is minus 1. So X is equal to 3 times minus 1 and plus 2. Then X1 is 2 divided by M plus N. M is 3 plus 2. 3 times minus 1 is minus 3 plus 2 times 2 is 4 divided by 2. 3 plus 2 is 5. So minus 3 plus 4 is 1. So X is equal to 1 over 5. So we found the X component of M. Let's find the Y component. The Y is, we just replace X1 and X2 by Y2 and Y1. So Y is M Y2 plus M Y1 divided by M plus n. So y is equal to, so like what we did, this is x1, y1, then x2, y2, and this is m and this is n. So my2, m is 3, then y2 is 2 plus n is 2, then y1 is minus 3 divided by m plus n, which is 3 plus 2. So y is equal to 3 times 2 is 6 plus 2 times minus 3 is minus 6 divided by 3 plus 2 is 5. So y is equal to 6 minus 6 divided by 5. Therefore y is equal to 0. So we now have our point. The x component is 1 over 5 and the y component is 0. And therefore m is equal to 1 over 5 I plus 0j. 0j is just 0. So m is equal to 1 over 5 I. If p equals column vector 5, 6 and q equals column vector minus 1, 0 and r equals column vector 5, minus 2, find the values of the constant x and y such that 2p is equal to 5x³ minus 3yr. So the equation is 2p equals 5x³ minus 3yr. So we are going to find the values of x and y. So 2 times p is a column vector 5, 6, is equal to 5x times q is a column vector minus 1 and 0 minus 3y, r 3yr, r is a column vector 5 minus 2. So let's go ahead and multiply. 2 times 5 is 10, 2 times 6 is 12, equals 5x times minus 1 is minus 5x. Then 5x times 0 is 0. Then minus 3y times 5 becomes, so let me bring plus here, minus 15y. Then minus 3y times 2 becomes plus 6y. So 10, 12 equals, writing this as a single column vector, becomes minus 5x minus 5y. So minus 5x minus 5y. And the denominator and the down here becomes 0 plus 6y, which is 6y. So we can then write this into two equations and solve them simultaneously. So consider minus 5x minus 5x minus 15y is equal to 10. So let's divide through by minus 5. So I divide here by minus 5, this portion 2 by minus 5, this portion 2 by minus 5. So minus 5 and minus 5 cancel, we are left with x. Minus 15 divided by minus 5 is plus 3y. Cos 10 divided by minus 5 is minus 2. So this is equation 1. And then equation 2 is 6y equals 12. So if we divide through by 6, here 2 by 6, see that y is equal to 2. So we need to put y equals to 2 back into this equation to find the value of x. So x plus 3 times 2 equals minus 2. So x is equal to minus 2 minus 3 times 2 is 6. And therefore x is equal to minus 2 minus 6 is minus 8. Given that the vector p equals 2, minus 3, and vector q equals 4, 2, and vector r equals 3 minus 2. Find A, 4p minus 2q plus 5r, and B, the position vector who divides vector p and q in a ratio 2:3. So let's solve the A part, which is 4p then minus 2q plus 5r. This is equal to 4 times vector p is 2 minus 3, and then minus 2q. Q is also 2. Q is 4, 2, and then plus 5 times r. R is 3 minus 2. So this is equal to 4 times 2 is 8, and 4 times minus 3 is minus 12. Then plus minus 2 times 4 is minus 8. Minus 2 times 2 is minus 4. Then plus 5 times 3 is 15. And 5 times minus 2 is minus 10. So this is equal to, let's write this as a single vector, column vector. It's 8 minus 8 plus 15. Then here is minus 12 minus 4 minus 10. So this is equal to 8 minus 8 is 0 plus 15 is 15. The minus 12 minus 4 is minus 16. And minus 16 minus 10 is minus 36. The second part of the question says the position vector who divides p and q in the ratio 2:3. So let me draw it here. Let's assume this is the point P, and P is a vector 2 minus 3, and then Q vector 4, 2, which is coordinate 4, 2. So it says that we should find the position vector. So let's assume that that position vector is a x of y, xy, and it divides it in the ratio 2:3. So this is 2 and this is 3. So this is x1, y1, and this is x2, y2, and this is n, and this is n. So let's write the formula for the internal division of a line in the x component. So x is equal to mx2 plus nx1 divided by m plus n. So x is equal to m is 2 times x2, this is x2, which is 4, plus n is 3, times x1 is 2, divided by m plus n. M plus n equals 2 plus 3. So this is equal to 2 times 4 is 8 plus 3 times 2 is 6, divided by 2 plus 3 is 5. And then this is equal to 8 plus 6 is 14, divided by 5. So this is the x component. Let's find the y component. The formula for the y component is my1 plus my2 plus ny1 divided by m plus n. So y equals m is 2, y2 is 2, plus n is 3, then times y1 is minus 3, divided by m plus n, which is 2 plus 3. So y equals 2 times 2 is 4, 3 times minus 3 is minus 9, divided by 2 plus 3 is 5. This is equal to 4 minus 9. It's minus 5 divided by 5. And this is equal to minus 1. So the position vector A, so let me use small caps. So the position vector A is equal to, the I component is 14 divided by 5I. Then the J is minus 1, so minus J. If A 26, B 22, C 73, and D XY are the vertices of a parallelogram ABCD, calculate the coordinate DXY. So let's draw a parallelogram here. So this is the parallelogram. Then we have A, B, and then C, D. So what are the coordinates of A? A is 26, and then B is 22, and C is 73, and then D is XY. But because it's a parallelogram, we know that the vector AB is parallel to the vector DC, which means this vector is equal to this vector. So let's find the vector AB. The vector AB is position vector OB minus position vector OA. And then let's also find the vector DC. The vector DC is position vector OC minus position vector OD. So since they are parallel, then we can say that vector AB equals vector DC. So let's equate AB and then DC. AB is OB minus OA equals OC minus OD. But at the end of the day, we are looking for D, so let's make D the subject. So OD equals OB minus OA. Then if I take OC, I made a mistake. Let me bring OD to this side and take both OB and OA to this side of the equation. So minus OD becomes OD equals to OC. Then OA minus OA becomes plus OA. Then OB becomes minus OB. So these are all position vectors. So position vector D equals OC, which is 73, then plus OA, which is 26, and minus OB, which is 22. So OD equals, let's write this as a single column vector, 7 plus 2 minus 2, and 3 plus 6 minus 2. So position vector OD equals 7 plus 2 is 9, minus 2 is 7. Then 3 plus 6 is 9, minus 2 is also 7. So DXY, the coordinates of DXY are 7, 7. The position vectors of points PQRS relative to a fixed point O are vector P equals 2I plus 3J, vector Q equals 6I plus 23J, vector R equals 2I minus 7J, and vector S equals 7I plus 4J. Find the scalars M and N such that S equals MP plus NQ plus R. So the formula is S equals MP plus NQ plus R. So let's write all of this. S is 7I plus 4J, which is 7 and 4. Then this is equal to Sorry, let me write m. I forgot about m. M times p. P is 2i plus 3j, which is 2 and 3. M plus n. Q. Q is 6i plus 23j. Then plus r. R is 2i minus 7j, so here becomes minus 7. I want to bring this column vector to the left hand side. It becomes 7, 4 minus 2 minus 7 equals m. So m times 2 is 2m. Then m times 3 is 3m. M plus n times 6 is 6n, and n times 23 is 23n. This is equal to, let's write all of this as a single vector. 7 minus 2, then 4 minus 7 is 4 plus 7. And this is equal to 2m, 3m plus 6n, 23n. So 7 minus 2 is 5. And 4 plus 7 is 11. This is equal to, in one bracket, 2m plus 6n, then 3m plus 23n. So we need to write this as two separate equations and solve them simultaneously. So 2m plus 6n equals 5, equation 1. And then 3m plus 23n equals 11, equation 2. So let's multiply equation 1 by 3 and equation 2 by 2. So equation 1 times 3, what will we get? 3 times 2 is 6. 3 times 2m is 6m, plus 3 times 6n is 18n, equals 3 times 5 is 15, equation 3. And let's multiply equation 2 by 2. So 3m times 2 is 6m, and plus 23n times 2 is 46n, equals 11 times 2 is 22, equation 4. So let's subtract equation 3 from equation 4. So we have 6m minus 6m plus 46 n minus 18n equals 22 minus 15. 46 minus 18 is 28n, equals 22 minus 15 is 7. This implies that n is equal to 7 divided by 28. Therefore, n is equal to 1 over 4. So let's take n equals 1 over 4 and then put it in equation 1. But from equation 1, we know that 2m is equal to 5 minus 6n. I'm just making m the subject. So m is equal to 5 minus 6n divided by 2. So m is equal to 5 minus 6 times n. N is 1 over 4. So 1 over 4 divided by 2. So this is equal to 5 minus 6 divided by 4 will become 3 over 2. So 5 minus 3 over 2 divided by 2. 2 times 5 is 10. 10 minus 3 is 7. So we have 7 over 2 divided by 2, which is equal to 7 divided by 4. So therefore, the value of n is equal to 1 over 4, and then the value of m is equal to 7 over 4. The coordinates of points P, Q, and R are 3, 1, minus 3, 4, and 1, 2, respectively. Find A, 3PQ plus 2QR, and B, the unit vector in the direction of PR. So let's find PQ. PQ is the position vector OQ minus the position vector OP. And this is equal to OQ. Let me first write the vectors down. So it's PQR. So that means that P is 3, 1. And then Q is minus 3, 4. And then R is 1, 2. So OQ is minus 3, 4. Then minus OP is 3, 1. So this is equal to minus 3 is minus 6. And then 4 minus 1 is 3. So the vector PQ equals minus 6, 3. Let's find the vector QR. QR is the position vector OR minus the position vector OQ. And what is OR? OR is 1, 2 minus OQ. OQ is minus 3, 4. So this is equal to 1 minus 3 is 4. And 2 minus 4 is minus 2. So since we now know PQ and QR, we can then find 3PQ plus 2QR. So 3PQ plus 2QR is equal to 3 times PQ, which is minus 6, 3, then plus 2 times QR. QR is this, which is 4 minus 2. So this is equal to 3 times minus 6 is minus 18, and 3 times 3 is 9. Then plus 2 times 4 is 8, and 2 times minus 2 is minus 4. So minus 18 plus 8 is minus 10, and 9 minus 4 is 5. So therefore, 3PQ plus 2QR is equal to minus 10 and then 4. The B part of the question says we should find the unit vector in the direction of PR. But then we know that PR is equal to PQ plus QR. Law of addition of vectors. So what is PQ? We know PQ. PQ is minus 6 and then 3. And then plus QR. QR is 4 minus 2. So this is equal to minus 6 plus 4 is minus 2. And 3 minus 2 is 1. So PR is minus 2, 1. However, because we are looking for a unit vector, we need to find the magnitude of PR. So what is the magnitude of PR? It's square root of minus 2 squared plus 1 squared. Minus 2 squared is 4. Then plus 1 squared is 1. And this is equal to root 5. So the unit vector of PR equals the vector over the magnitude, and the vector of PR is what? Minus 2i plus j. So minus 2i plus j divided by the magnitude, which is root 5. So we can rationalize by multiplying by root 5 over root 5, so that the unit vector becomes root 5 over 5 times minus 2i plus j. It says that ABCD is a parallelogram such that AB equals 3i plus j, and AC equals 5i minus 3j. Find A, the vector BC, and B, the vector BD, and C, the unit vector in the direction of BC. So let's draw a parallelogram. So let's assume this is a parallelogram, and then the parallelogram is A, B, and A, B, C, D. So let's assume this is A, B, and then C, D. So now it says that AB is 3i plus j. So we are looking for what? The first part, we are looking for BC. So BC. So that means that this one will be going to this side since they are equal. And then BD. This is BD. So this way. So it means that this will be coming here, and this one to go in this direction, since AB is equal to DC. So let's write the formula for finding BC. BC is equal to BA, vector BA plus vector AC. So let me draw a dotted line here. So BC is the vector BA plus the vector AC. So that is true. But the question, they give us AB. So BA is just going to be the negative of AB. So BA, vector BA is equal to negative the vector AB. So BC, vector BC is equal to, when you negate AB, minus AB, and AB is 3i plus j, then plus AC. AC is 5i minus 3j. So BC is equal to minus 3i plus 5i, then plus j minus 3j. So this is equal to minus 3i plus 5i is 2i. And then, sorry, I made a mistake here. So minus 3i plus 5i, then minus 1 times j becomes minus j. This place is minus j. So minus j minus 3j is equal to minus 4j. So we found BC. BC is 2i minus 4j. Now let's find BD. Vector BD is BA, vector BD. It is BA plus AD. So plus AD. So what is the vector BA? We're given AB, so BA is just a negative of that word, which is minus into brackets 3i plus j, then plus AD, then plus AD. However, since it's a parallelogram, you can see that AD is equal to what? BC, because those two vectors are parallel vectors, and therefore we could replace AD with the vector BC. So this is plus 2i minus 4j. This is equal to minus 3i plus 2i, then minus j minus 4j. So minus 3i plus 2i is minus I, and minus j minus 4j is minus 5j. So in other words, BD is equal to minus into bracket I plus 5j. This is vector BD. And then the last portion is we should find the unit vector in the direction of BC. So let's find magnitude of BC. Magnitude of BC is equal to square root of, this is BC. So square root of 2 squared plus minus 4 squared. This is equal to square root of 2 squared is 4 plus minus 4 squared is 16, which is equal to square root of 4. Square root of 4 plus 16 is square root of 20. So this is equal to root 20, and root 20 is the same as 2 root 5. 2 root 5. But we know that unit vector is equal to vector over magnitude, and the vector is 2I minus 4j divided by the magnitude, which is 2 root 5. So we need to rationalize by multiplying both the numerator and the denominator by 2 root 5 over 2 root 5. So that this is equal to 2 root 5 then times 2I minus 4j divided by 2 root 5 times 2 root 5 becomes 4 times 5. So we can factorize 2 out. So this is equal to 2 times the factorized 2 becomes 4 root 5. Then times, since we factorize 2 out, this becomes I minus 2j divided by 4 times 5. So this 4 and 4 cancels out. And this is equal to root 5 over 5 times I minus 2j. The position vectors of A and B are A equals 3I minus j and B equals 2I plus 3j respectively. Find correct to 2 decimal places the magnitude for A minus 2B. So for A minus 2B is equal to 4 times A. A is 3 minus 1, and then minus 2 times B. B is 2 and 3. So this is equal to 4 times 3 is 12, and 4 times minus 1 is minus 4. Then plus minus 2 times 2 is minus 4. Minus 2 times 3 is minus 6. So this is equal to 12 minus 4, then minus 4 minus 6. So this is equal to 12 minus 4 is 8, and minus 6 minus 4 minus 6 is minus 10. So it's equal to 8 over minus 10. However, the question said we should find the magnitude of 4A minus 2B, and that is equal to the square root of 8 squared plus minus 10 squared. This is equal to square root of 8 squared is 64 plus minus 10 squared is 100. Square root of 64 plus 100 is 164. The square root of 164 is 12.81 units. A with coordinates 3, 1, and B with coordinate minus 1, 9, and C with coordinates 1, minus 2 are vertices of the triangle ABC. E is a point on AB such that magnitude of AE equals 1 over 3 magnitude of AB. Find A, the vector AB, B, the vector AC, and then C, the vector CE. So let's sketch the triangle. So this is how our triangle will look like. triangle ABC. So the coordinates of A are 3, 1. The coordinates of B are -1, 9. The coordinates of C are 1, -2. And E is the point on AB said that AE is equal to magnitude of AE is equal to 1/3 magnitude of AB. So it means that if EB is 3, AE is 1, so that the magnitude of AE is equal to 1/3 the magnitude of EB. So the ratio is 1:3. So let's first find AB. What is vector AB? Vector AB equals vector OB minus position vector OA. So what is the position vector OB? OB is -1 and 9 minus position vector OA, and then OA is 3 and 1. So this is equal to -1 minus 3 equals -4. And then 9 minus 1 is 8. And therefore the vector AB is -4 and 8. Let's find the vector AC. It's equal to the position vector OC minus position vector OA. So what is position vector OC? OC is 1 minus 2. So 1 minus 2 minus OA. OA is 3, 1. And this is equal to 1 minus 3 is -2. And -2 minus 1 is -3. And therefore vector AC is -2 minus 3. So now we are supposed to find vector CE. So we found vector AB as -4 and then 8, and then vector AC as -2 minus 3. So we are looking for vector CE, and we know that CE is equal to vector CA plus the vector AE. So vector CE is equal to vector CA plus AE. However, we know the vector CA because we know AC. So CA is just the negative of AC. But what we don't know is the vector AE. How do we find the vector AE? We see that the vector AE is equal to 1 plus 3 is 4. So it's 1/4 the vector AB. 1/4 the vector AB. So AE, vector AE is equal to 1/4. Then we got the vector AB as -4 and 8. So AE is equal to 1/4 times -4 is -1. And 1/4 times 8 is 2. So vector AE is -1 and 2. So since we know AE and CA, we can find CE. So vector CE, which is equal to vector CA plus vector AE, is equal to CA. But we know AC. AC is this. So CA is -2 -3 plus the vector AE. AE was what we found, -1 and 2. So this is equal to -1 times -2 is 2. -1 times -3 is 3 plus -1 and 2. So this is equal to 2 minus 1 is 1. and 3 plus 2 is 5. So the vector CE is 1 and 5. So vector CE is equal to 1 and then 5.